Welcome, Algebra 1 students. Today we're going to start our first day of solving quadratics. So the first lessons that we've done so far when we've been dealing with quadratics, we talked about key features and we talked about graphing. Now we're actually going to work on solving to find solutions, or another word for solutions are those zeros or those roots, or most commonly probably the way I refer to it as those x-intercepts. So a little joke to start off your day, because I'm sure you've missed my jokes since we haven't been meeting in person. It says, what is the hidden math term? Bola. There's two of them, so it's a parabola, so parabola. I'm sure you're just rolling around laughing right now. So hopefully you enjoyed that. So let's go ahead and get into solving quadratic equations. Today specifically we're going to solve quadratic equations where there is no b value. Meaning our quadratic is going to look something like this. Ax squared, there's no b value, so there's no bx, so just like plus c is equal to 0. And that's what we're going to solve today. Solving quadratics where there is no b value. So just as a little refresher here on the side, it says a quadratic equation is in this form, ax squared plus bx plus c. A can't be 0. Today we're going to look for those solutions, and graphically, remember the solutions are the x-intercepts. A quadratic function can either have two solutions, like we see up here in this picture, we have two x-intercepts, so it has two solutions. It can either have one solution, or it could have no real number of solutions, meaning it never crosses that x-axis. But again, we're going to do this algebraically today, and we're not going to have a b value today when we solve. In order to solve quadratics that do not have a b value, we're going to have to use square roots. So just as a quick review, remember square roots and squaring something, they undo each other. They're inverse operations. So for instance, we know how to find the square of a number. So for instance, 3 squared equals 9. So then if we went in reverse, we could say, well, the square root of 9 is 3. Right? What we did before when we were doing square roots is we always found something called the principal square root. Which means whenever we took the square root, we always just got a positive number, right? The square root of 9 is 3. The square root of 64 is 8. The square root of 81 is 9. However, when we deal with equations, we don't want just the principal square root, simply because if you agree that 3 squared equals 9, right? So then 3 is the positive square root of 9, so the square root of 9 is 3. But if you said negative 3 squared was 9, then if we take the square root of 9, shouldn't that also be a negative 3? Because if they undo each other, right, if we undo these things, those would cancel out. I get 9. If I undo the square here, square roots and squares undo each other, and I should get here negative 3. So what we're going to see today when we're doing equations, right, this holds true when we do equations, when I take the square root of something, I'm going to get a positive and negative answer. So for instance, if I had x squared equals 9, and I want to solve this equation, what I would have to do is I'd have to take the square root of both sides, right, because I just want what x equals. So I get x equals, because square roots and squares undo each other, the positive and negative square root of 9. Well, we know the square root of 9 is 3, so I get a positive and negative 3. I often write in this notation. You could also say, x equals 3 and negative 3. If you wanted to write it like that, I like to just write it in this notation because it's a little bit quicker. Again, the reason why this works, if we just check our answers by plugging them back in, if I plug in first a positive 3, would you agree that 3 squared equals 9? Yep, that one holds true. What about if I plugged in a negative 3 for x? Is negative 3 squared also 9? Yeah, so that's why we have two solutions. When we're taking a square root in an equation, we have to now make sure we add this very important piece, this plus or minus, because we have to make sure we have both solutions. So let's just jump into some examples. That'll maybe make some of this a little bit more clear. So This is called the square root method, or when there's no b-value method. Okay, when the b-value is 0. Then it's easy to solve for x by isolating it to one side of the equation. So we can just go ahead basically and just solve these equations back like we did in Unit 1. So if I wanted to get x by itself to find my solutions, remember we cover up the x and I have to get rid of that minus 4 first. So I'm going to go ahead and add 4 to bring it to the other side. So now I'm left with x squared is equal to 4. To get x by itself, to get rid of the square, I have to do the inverse operation of squaring, which is taking the square root. So square root and square cancel each other out, so I just get x is equal to, before I evaluate what the square root of 4 is, I know I now have to add a plus or minus square root of 4, because I need both the positive and negative answer. So I get x equals a positive and negative square root of 4, which is 2. So I get two solutions, x equals 2 and x equals negative 2. Those are my two answers. Again, if you wanted to verify, you definitely could. If you plug in 2 squared is 4, so 4 minus 4 is 0. So that holds true. If I make this now a negative 2, negative 2 squared is also 4, minus 4 still gives me 0. So that's our final answer. If we do a couple more here, again, the big idea is just getting the variable by itself. So on this one here, I'd have to add 11 to the other side to get b by itself. So I get b squared equals 11. Again, I want to get rid of the square, so I have to take the square root of both sides. So I get b is equal to a positive and negative square root of 11. Since we don't know what the square root of 11 is, since it doesn't simplify nicely for us, I'm okay if you just want to leave it like this here. If it asks you to simplify and maybe they want a decimal answer, then you can go ahead and definitely just plug that into your calculator. Let's just do this so if we're all on the same page. If I say that decimals are okay, let's just always round to 2 decimal places. So I could say b is a positive and negative 3.32, I believe, if you plug it into your calculator. Again, I'd prefer if you just leave it in radical form unless I say otherwise. So we'll just leave it as that positive and negative square root of 11. One more here before we move on. It looks like here we have d squared equals 81. The nice thing here is our variable is already by itself. So that means I just have to undo the square. So I'm going to take the square root of both sides. So the square root and square cancel each other out. So I get d equals, it's an equation, I got to have the positive and negative square root of 81. Well, the square root of 81 is 9, so d is equal to a positive and negative 9. All right, those are my two solutions. And again, remember our solutions are just x-intercepts on our graph. So our two x-intercepts are at 9 and negative 9. So really, if we were thinking about this graphically, these would be 2 points, right? It'd be a point at 9, 0, one x-intercept, and another point at negative 9, 0. That's where they would cross. That y-intercept, or sorry, that x-intercept. Excuse me, those are the x-intercepts. So there was some review problems. Let's just do a few more because there's some interesting things that happen. Again, we know we can solve these quadratics using square roots because there is no b-value. If there's a b-value, we're going to talk about different ways to solve. We can't use square roots. But here, I noticed for all of these, there's no b-value. So I'm just going to go ahead and just solve for my variable. So I'm going to try to get it by itself. So on this first one, it's pretty slick. Add 36 to the other side. Get x squared equals 36. I know to undo squares, I got to take the square root of both sides. Those cancel each other out. So I get x is equal to a positive and negative square root of 36. Hopefully you know by now the square root of 36 is 6. So I get a positive and negative 6. I have two solutions. X is 6 and x is a negative 6. Same idea for this middle one. I add 15 to the other side. So it looks like I get p squared equals 15. Again, now I got to take the square root of both sides. Square root. So I get p is equal to a positive and negative square root of 15. Square root of 15 isn't one of those perfect squares, and it's not one we can simplify, right, by making our factor trees and looking for buddies. So if we broke down 15, it'd be 3 times 5. So there's no groups of 2 that we can pull out. So I'm just going to leave it just like this. So again, that means I have a solution of square root of 15, and p would equal a negative square root of 15. Those are my two solutions. Again, I prefer this notation up here that I circled. Last one here of just kind of these basic examples, and we'll make them a little bit harder. On this one, again, you would want to solve for r. So we gotta first subtract the 25 to the other side. So I get r squared is equal to a negative 25. We then have to undo square roots, so I gotta square each side. So then I get r is equal to, well, if we look up here, if you remember back to when we worked with radicals, hopefully you're thinking, gosh, I don't think I can take a square root of a negative, and you'd be correct, right? We can't take a square root of a negative because we say square roots undo squares, and I can never square a number and get a negative. So I can't take the square root of a negative number. So for this one, I would say no solution. Again, no solution doesn't mean I can't graph this thing. I could definitely still graph it. It'd be something like way up here, because this plus 25, if I remember from vertex form, tells me I'm going up 25. So let's pretend I'm up 25 here. Just means my graph is going to open up this way, and it's just not going to have any x-intercepts. That's what those no solutions means. I can still make a graph, just no x-intercepts here. Again, the reason being is I can't take the square root of a negative number. Just a couple slides left here. It says, which of the following quadratic equations has no real solutions? So why don't you think about this for about 10 seconds. Well, hopefully you thought, well, if I just solved each of these, if I subtracted this one, I'd have subtract 4, so I get d squared is equal to a negative 4. So if you took the square root, that one would not have a real solution, right? Or we'd say no solution here. A lot of times we say no real solutions just because once you get into algebra 2, you'll talk about imaginary numbers and you'll be able to find the imaginary solutions for these. But for us, we just say no solution or no real solution. So 1 definitely has no solution. Same thing with 2, because if you bring the 16 to the other side, again, you get it set equal to negative. You'd have to take the square root of a negative, so that'd be no solution. 3 and 4, those ones will work out okay because you'll be taking the square root of a positive, so you'll have 2 solutions there. For 3, it won't work out super nicely, but that's okay. You'll still have 2 solutions. So the only 2 that do not have any real solutions, or they don't have a solution, are 1 and 2. So hopefully you would have thought, well, it should be B. All right, just a few more examples here. These next ones are just a little bit more complicated in terms of there's just more stuff going on. So again, same idea though. If I want to solve for t, right, I should notice there's no b value, so that means I can use the square root method to solve. So to get t by itself, I remember I cover up the t, so I know I have to move the 100 to the other side first. So I get 4t squared is equal to 100. Next, before I can do square roots, I have to divide by 4 to get just t by itself. So I get t squared is equal to 100 divided by 4, which is 25. Finally, I get to go ahead and take the square root of both sides. So I get t equals a positive and negative square root of 25. Right? It's both when I'm taking the square root and an equation. So I get t is equal to a positive and negative 5. There's my solution. Let's try maybe one more here. I don't know that we need to do a ton of these. Or maybe 2 more. Let's do 2 more. Let's do this one first. So here again, if I'm solving for d, I'd add 54 to the other side. I get 6d squared is equal to 54. Before I can take the square root of both sides, I have to get d all by itself. So I'm going to go ahead and divide by 6 on both sides. So I get d squared equals, well, 54 divided by 6 is 9. Now I'm going to go ahead and finish it off, take the square root of both sides. So I get d is equal to a positive and negative square root of 9. So d equals a positive and negative 3. Square root of 9 is 3. Please do not forget, again, this is the big idea when you're taking the square root of an equation. We need the positive and negative answer. So you need to put the plus or minus. That's super important. Last one here. Let's do this one, this first one. And if you wanted to pause the video and try this one on by yourself, that probably wouldn't be a bad idea. But here, if I'm solving for x, I'm going to add 15 to the other side. So I get 5x squared is equal to 15. I'm now going to go ahead and solve for x. So I'm going to divide by 5 on both sides. So I get x squared is equal to 3. Things are fine because I'm set equal to a positive. So when I take the square root, I know I'll get solutions. So I get x, right, because the square root and square cancel each other out, is equal to the positive and negative square root of 3. Square root of 3 is not one of those perfect squares. So that means it's not going to work out nicely. It's not going to be a nice whole number. So I'm just going to leave it just like this. So again, this tells me I'd have an x-intercept at square root of 3 and negative square root of 3. So this is how we solve quadratics when there is no b value. We can use what we call the square root method. If you'd like to try this one, I'll leave this one open for you. Just on this next couple pages here, I just have the first 20 perfect squares. Probably even more helpful than that is this page right here, the square roots, the first 20 perfect squares. Again, it's super helpful if you know at least up through this one here. The square root of 169 is 13. Right, if you know everything under that, it'll make these problems go quite a bit faster for you. Again, this is the same slide as I used before. Make sure you add, when you're looking at this one, add a 0 there. Square root of 100 is 10, not square root of 10. So again, the more of these you know, the better off you're going to be. So this was our lesson on solving quadratics using square roots for your homework today. So you get 10 points just for watching this video. And then your homework is going to be on quizzes.com, and I have a link on Classroom. You're going to go enter the class code. It's kind of like a Kahoot game, but it's not live. There's just 8 questions for you to do wrapped around this idea. So please make sure you go complete that as well. As always, if you have any questions, email me at storeandflip@gmail.com. Thanks and have a great day.